So last class we started talking about Riemann sums for estimating the area under a curve. And today we're going to look at that a little bit more in detail and look at some more examples. So first example, and you guys can kind of fast forward or slow down the video as you please. Use the left-hand Riemann sum with 4 evenly spaced partitions to estimate the area under the curve y equals x squared minus 9 from x equals 1 to x equals 3. So we're using a left-hand Riemann sum, and we want 4. So that means we're making 4 rectangles, and those rectangles are going to touch our function on the left side of the rectangle. So first thing we need to do is think about a graph. So if you remember from last time in class, you guys were given a graph to start with. Well, here you have to graph it yourself. Now this function, y equals x squared minus 9, should be kind of familiar to you because in Algebra 2 you're asked to graph with transformations. So you guys know what x squared looks like, and so x squared minus 9 just shifts the graph down 9 spaces. So y-axis, x-axis, here's negative 9, and now my function's a quadratic, and it looks something like this. All right, now I want to know where it hits the x-axis so that when I'm making my rectangles, I know where I'm drawing them to. So I'm just going to think real quick about, okay, x-intercept, that means 0 equals y. So if I add 9 and I take the square root and I add my plus or minus 3 and negative 3. So I know that it hits here at 3 and here at negative 3. Okay. So second thing is mark partitions and draw rectangles. So we want to find the area under the curve from x equals 1 to x equals 3. So 1, 2, 3. And we want to use 4 evenly spaced partitions. So if I'm going to do 4 partitions, that must mean that I have to actually cut these in half again. So 1, 2, 3, 4. So I have one at 1, one at 1.5, 2, 2.5, and then 3. Now I'm going to draw my rectangles. Now because I'm doing a left-hand Riemann sum, I'm going to start on the left side. So I'm starting at 1, and I'm going to go from 1 down to the function, over and back up. Then I'm going to go from 1.5 down to the function, over and up. And now 2 down to my function, over and up. And then 2.5 down to my function, over and up. And I don't need to do it from 3 because I've already finished my 4 rectangles. So when you start with a left hand, or when you do a left-hand Riemann sum, you start from the left, and then your last number you don't actually use to form a rectangle. Okay? So I did step 2, I marked my partitions and I drew the rectangles. Now I want to find the area of them. So I need to know the width of each rectangle. So I'm going to call that width delta x, because that means change in x. My change in x here is 0.5, so that's my width. Now I'm going to use that width, and I need to find the height of my rectangles so that I can figure out the areas. So we've got rectangle 1, rectangle 2, rectangle 3, and rectangle 4. Now, to find the height of each rectangle, I need to plug in my x value into the function so that I can figure out where exactly or how high or how low it goes. So for example, I want to find out this height, I need to plug in 1 into my function. So y equals 1 squared minus 9. So that gives me negative 8. For the second one, I'm going to plug in 1.5. So 1.5 squared minus 9. And that's see here, 1.5 squared minus 9. So it's negative 6.75. And rectangle 3, we're at y equals 2, so 2 squared minus 9. So that's 4 minus 9, so negative 5. And then rectangle 4, I'm plugging in 2.5. And 2.5 squared minus 9 is negative 2.75. So these are my heights. So I've got negative 8, negative 6.75, negative 5, and negative 2.75. Now, determine the area of each rectangle and add the areas. So rectangles, area, length times width. So I'm going to go negative 8 times 0.5 plus negative 6.75 times 0.5 plus negative 5 times 0.5 plus negative 2.75 times 0.5. And we'll do some quick math. Negative 8 times 0.5, negative 6.75 times 0.5 plus negative 5 times 0.5 plus negative 2.75 times 0.5. All right, so I got negative 11.25. Now, then that's units squared because we're talking area. So the last question here says, is this estimate an overestimate or an underestimate? Well, you got to look at your rectangles and see if your rectangles are not quite filling up that curve or if they're overfilling it. And in this case, they're extending beyond the curve, so this is an overestimate. Okay. Now you notice that our area is negative, so I want you to ask yourself, why is the area negative? And I think most of you guys would figure out that it's negative because it's under the x-axis, because our y values are negative. So whenever you have area that is under the x-axis, it's going to be negative. Okay, so all this area under here is negative. Whenever you have area above the x-axis, that's considered positive. So in this case, from 0 to 2 pi, we get positive area and negative area that are the same size. They would actually cancel each other out, and you would have an area of 0. So area above the x-axis is positive, and area below the x-axis is negative. Okay, and we've got a couple more examples to go through here. So use the right-hand Riemann sum. So this time we're doing a right-hand Riemann sum with 4 evenly spaced partitions to estimate the area under the curve y equals 9 minus x squared. And we're going from 0 to 4. So first of all, y equals 9 minus x squared. That's the same thing as y equals negative x squared plus 9. And if you remember from Algebra 2, adding 9 shifts your function up 9 spaces, and this negative out front makes it reflect over the x-axis, so it's a frowny face. So this is going to be up 9, and it's going to go down like this. And I'm going to ask myself the same question. Where does it intersect the x-axis? So it's going to intersect again if we make y equals 0. And we solve this, you end up getting 3 and negative 3. So it intersects here at 3 and here at negative 3. Now we want to go, so I sketched the graph. Step 2, mark partitions and draw rectangles. So marking my partitions, I'm going from 0, 1, 2, 3, 4. So there's my 4 spaces, and it goes from 0 to 4, so I'm all set. Determine the width, and draw rectangles, sorry. So we're using a right-hand Riemann sum. So instead of starting on the left side, I'm starting on the right side. And this function needs to be extended a little more down here. There we go. Okay, so I'm going to start on the 4, because that's on the right-hand side, and I'm going to go down to my function, over, and up. Now when I'm at 3, I'm going to do the same thing. I'm starting on the 3, I'm going to my function, which I'm actually already on, and then I'm going to go over and back to the x-axis. So you'll notice this is kind of a weird case, but the right-hand rectangle here is just a straight line. It has no area, all right, because we're starting at 3, and since we're already on the x-axis, you're not going up or down at all. Just go straight over. There's your rectangle. All right, 2, go up to the function, over and down, and then 1, go up to the function, over and down. It's not as easy to see if this is an overestimate or an underestimate here, because on the top we're below the curve, and on the bottom we're actually extending beyond the curve, so it's hard to tell. But let's keep going. So determine the width of each rectangle. So delta x equals 1, so that's our width. Determine the height of each rectangle. So I'm going to start on the left, and I'm going to call that rectangle 1. Then we've got rectangle 2, rectangle 3, and rectangle 4. So the heights. My height for rectangle 1, this first one comes from using x equals 1. So I'm going to plug in 1. So we've got y equals 9 minus 1 squared, which is 8. Rectangle 2, we're going to use 2 to figure out that height. So y equals 9 minus 2 squared, so 9 minus 4, so 5. Rectangle 3, we're going to use 3 to figure out the height. So y equals 9 minus 3 squared, which is 9 minus 9, which is a height of 0, which shows up in the diagram. And then rectangle 4, we're going to use 4, so y equals 9 minus 4 squared. 4 squared is 16. 9 minus 16 is negative 7. So those are all of my heights, rectangle 1, 2, 3, and 4. Now determine the area. So we're going to multiply length times width. So we've got 8 times 1 plus 5 times 1 plus 0 times 1 plus negative 7 times 1. And so that ends up equaling 8 plus 5 minus 7, so 6 units squared. Now, is this an overestimate or an underestimate? Well, it's kind of hard to tell, so you can't really tell completely. Tell. And this is because some of the rectangles are above and some of the rectangles are below. All right, next slide. So now we're going to use a midpoint Riemann sum. So we used a left-hand one and we used a right-hand one. And this example is the hardest one, so make sure that you're really paying attention. If you have questions, stop and try and get them answered. So we're estimating the area under the curve y equals cosine x. So first thing is you got to remember what cosine looks like. Cosine starts at 1 and goes down to negative 1. And we number by pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So I'm going to start at 1, midline, bottom, midline, top, midline, bottom, midline, top. And I'm going to connect with a smooth curve. Connect, connect. Okay. So we're going from 0 to pi, and it wants 3 evenly spaced partitions. So I'm going to divide from 0 to pi into 3 spaces. So those are about even. Now if I'm dividing it into 3, that means each one is a third. So this is a third of pi, so pi over 3. And this is 2/3 of pi. And then this last one here is 3/3, which is just pi. Okay? Now when it says the midpoint, that means that you're in the middle. So right here, and I'm going up to the graph from the middle of my interval. So I'm at the middle, and I go left, right, and down. Now the middle here, between pi over 3 and 2 pi over 3, is actually on the graph here. And so this is the case like before, where if the top of your rectangle is actually on the x-axis, then your rectangle doesn't have any height. Okay, now between 2 pi over 3 and pi is about here. So I'm going to go down to my function, over and up. Okay, so let me try and make this a little bit clearer. Here's one rectangle. The other rectangle is actually on the x-axis. And then my second rectangle is, or my third rectangle, sorry, is over here. So if you look at those, we've got one above, one below, one in the middle that actually doesn't have any area. And we know above the x-axis is positive and below the x-axis has negative area. So this area actually just cancels out and becomes 0. Okay, so I know that my final answer is 0 units squared. And you really don't even have to do any work on this problem. If you did want to do work and you did want to prove it using your math, this is what you would do. So we would say, okay, determine the width of each rectangle. Well, each width is pi over 3. Determine the height. Well, what you need to think about to get the height is this y value here. Halfway between 0 and pi over 3 is pi over 6. So I would be plugging in pi over 6 into my function. So I would say rectangle 1, rectangle 2, rectangle 3. And I would say y equals cosine of pi over 6. And if you remember back to pre-calc, cosine of pi over 6 is square root 3 over 2. Rectangle 2. So rectangle 2, the middle of that's pi over 2. So we'd be plugging in pi over 2. So I'd say cosine of pi over 2. And if you think back to pre-calc, cosine of pi over 2 is 0, which makes sense because the height of that rectangle is 0. For rectangle 3, halfway between 2 pi over 3 and pi is, let me think about this. Let's see. It's 5 pi over 6. All right? So halfway between 2 pi over 3 and pi is 5 pi over 6. And you guys can do that math on your own. But I'm going to plug 5 pi over 6 in, and I get y equals cosine of 5 pi over 6. And if you look at your unit circle, think back to trig, cosine of 5 pi over 6 is negative square root 3 over 2. So then we would find the area. And so I would say square root 3 over 2 times pi over 3 plus 0 times pi over 3 plus negative square root 3 over 2 times pi over 3, and all of that would add up to be 0. Okay, and so that shows us that the area is 0 units. Is this an overestimate or an underestimate? You can imagine that this actually is going to be exactly what the area is, because the area in the top and the area in the bottom are actually going to cancel out. Okay, so that is that. I don't think there's, nope, that's the last example. So you guys can go ahead and take out the worksheet and take out the graph paper that I gave you and work through those 6 examples using what I showed you guys in the video.